Yeah, so welcome everyone. It's my first time at SATURN here, but it's been awesome so far. My brain is already exploding, and this is like day 2. I went to Paolo's workshop yesterday, and that was an awesome journey into microservices, which we'll touch on a little bit today. But this is mainly a kind of culmination of several projects I've worked on over the last few years with containers, with microservices, in the cloud, full buzzword bingo. But I made a bunch of mistakes, a few successes, but learned a lot of things along the way. So I'm going to try and share over the next 90 minutes some of my learnings. I'll kind of go through the core bits of the pipeline, and I'll stop at each sort of segment of the pipeline, about every sort of 10 slides or something, and I can open for questions there. Because I'm not sure if I've got 90 minutes worth of slides. Happy to take questions, but I can always ad-lib some bits and pieces and bring in some other bits of my talks I do as well, which I'll reference along the way. But to set the scene, I like to say that the expectations are pretty high around cloud and container tech. Yeah, you know, as an industry, we're a little bit hype-driven. We're a little bit fad-driven. I'm guilty as charged sometimes on that as well. And I think with containers, kind of what we're being sold is you just take your architecture, you carve it up, you put it in a container, and you ship it. Yeah, this makes everything lower friction, super easy to get stuff out in the wild. The reality that many of us here are dealing with is we have architectures that are a bit of a tire fire. Yeah? They may be old, they may be new, but they're somewhat challenging. And when you try and put these things carved up into containers, what you actually get is tire fire in a container. Yeah, this is not such a good look. And you'll notice the first responders here, this is what we refer to as DevOps in the industry. Yeah? And this is basically how I make my money as a consultant. Yeah? As you can tell, I'm sure, by the accent, based out of the UK. Interesting sort of history, I guess. I started as an academic, did a PhD in computer science. Then at the end of the PhD, I really started enjoying doing more practical stuff, coding, helping people. I kind of found my calling really being sort of an independent consultant. I've done a couple of CTO gigs. I've worked throughout the stack, for better or worse. I tend to be quite a wide person in terms of skills, not perhaps so deep. Some people call it E or T-shaped. If you were going to say sort of, like wide skills and maybe a couple of deep skills, tends to be operational stuff, did a bit of sysadmin work, tends to be Java as well, kind of my skill set. But I totally recognise that technology and teams are super important. I've got really into the tech sometimes, had to pull back, and then I've got really into the leadership part when I was a CTO, and then had to pull back into the tech. So I'm searching for this perfect balance of getting all these things right, you know, leading people, the kind of the teamwork side of it, but also using the right technology. I genuinely think, my first computer was an Amstrad CPC 464, very similar to the Spectrums and the Commodore 64, and as a kid in my bedroom, dreaming of all these things I could program, now all the technology is there for the taking. Yeah, cloud, containers, lots of different languages. Our hardest choice as architects is putting that all together and creating a comprehensive vision to make sure everyone is marching in the right direction. I think that's our challenge as architects now, yeah? That's what I'm struggling with personally. Setting the scene today, so continuous delivery is a very large topic, and I think super important things like value stream mapping, always look for bottlenecks. If you're deliberately going to bring in some new technology, some new practices, look at your bottlenecks in your organization. Some people phone me up and they say, bring in some Kubernetes, bring in some Docker. And when I get in there, I realize that Docker and Kubernetes are the least of their problems. Yeah? They can perhaps do QA, or they've got, like Rebecca mentioned in the keynote, communication issues and all these things. So we are not going to focus on that side of continuous delivery today. I also think technologies like PaaS, Cloud Foundry, a bunch of other cool things, are super interesting, but this talk is more skewed on kind of native containers. You're running something like ECS, Kubernetes, Mesos. We'll cover a few of those things as well, although I'll try and keep this a quite agnostic platform sort of talk. And we are going to focus on the processing tooling. I'm not going to live code. I'm really not very good at it. I leave it to the experts like Josh Long and many other people like that. I've got a mini book, and it's freely available online, courtesy of Nginx. Thanks to Nginx. It's not a promo book. It's they just sponsored it. It's a GitHub repo associated with it. You can download the code. It is Java flavored, of course, but you can set up a Jenkins pipeline, and kind of the book walks you through one example of building a pipeline we're going to talk about today. So if you're more of a hands-on person, you can pop along, grab the book. It's only a short little book, it's free, you can work through the examples. I will, at some points in the talk, say, oh, refer to the book, because it's just one example of how you might implement the kind of overarching pattern. Working for my sins on a full book, I never realised how much effort writing a full book would be. And Abraham Marin-Perez has joined me on this one now, so kudos to Abraham. But it's a very rewarding journey. It's really helped me put my thoughts together, but it's really time-consuming as well, writing a book. But that one's going to be out soon. So I like, when I'm doing lectures or talks or whatever, I like setting the scene up front, the kind of, busy person's guide. If you want to have a little afternoon snooze, I appreciate, it's after the cookies are good, yeah? If you want to just snooze. This is the kind of key takeaways that we're going to be addressing throughout the talk, and I'll summarise with these as well. The first one is that when we're now building a continuous delivery pipeline, and we're pushing something down, verifying it along the way, the container image becomes what we call the single binary. There should only be one copy of that, and it should flow down and we should test it. A couple of anti-patterns I've seen, people basically say build a jar, a .NET, or a Go app, and they only containerize it just before deployment. They do all their testing, all these other things, without a container, and then they deploy in a container. And the container alters the fabric of your runtime, so that's bad. I've also seen people repackage containers along the way. So they have like a dev and a test container. They have a QA container and a prod container. And you get subtle drift in those containers. So what I'm saying is the binary, the artifact, the thing we're now shipping down the pipeline must be a container image. You must put your language artifact in the container image. And it must be the same thing going down the pipeline. Yeah, don't repackage it at the end. Adding metadata is super, super important. If I was to say to you now, can you tell me exactly what versions of your applications are running in production, with exactly what dependencies, with exactly what security checks? Really, we all should be able to go, I can't exactly tell you now, but I can log on and show you. Yeah, we should be able to answer that. And I'll probably rag on Equifax a little bit, but Equifax, just the people who got caught. I'm sure many people are pushing their luck with security issues, but not knowing where things are and what you've got deployed is no longer an excuse. In the EU, in the UK, there's been talk around the Volkswagen scandal. Software engineers now are becoming legally liable for some of these things. So we, I think, are on the dawn perhaps of some more regulation, both in the US and the EU, and we as professionals, as architects, need to think about these things. We need to have some level of governance, some level of provenance, know what is running, has it been security verified, that kind of stuff. And as I mentioned already, the container does alter the fabric of what you're running on. So if you're running Python in a container, they're subtly different than running Python on bare metal, for example, and any language as well. And I'll pull out some of those things. And it does alter the kind of the way I tested in the past system quality attributes. We'll cover some of those things as well. So I wasn't sure, I'm very fortunate to present at many conferences, and every conference has its own culture and its own kind of understanding of skills. Like I wouldn't dare to tell any of you what architecture is. I think at SATURN we'll hear about that. But some conferences I talk at, I have to explain what architecture is, or what I think it is. But I wasn't sure of people's experience here. So in general, are people comfortable with continuous delivery? So sort of a few nods. And container technology, are people sort of familiar with Docker and so forth? Maybe not used it, but or played around with it or something like that. Okay, so let's see a few nods. So I'll go through these fairly quickly then. So continuous delivery, if anyone hasn't read the book, I sorely recommend this book. It's probably 10 years old, maybe now. It's a fantastic book by Jez and Dave. It uses older technologies, but like many timeless books, the principles and the practices and the values are much more important than the tech. This is a fantastic book to read. And continuous delivery is fundamentally about producing valuable and robust software in short cycles, getting rid of the big bang stuff. We're optimizing for feedback and learning. And that's throughout the organization. Yeah? Feedback and learning as developers, as architects, as operations people, these kind of things. Some organizations I go into get scared thinking that continuous delivery is continuous deployment. In that, as a developer, I might do a commit, and that commit instantly goes through to production if it passes some tests. Many organizations I work with are happy with doing that. They actually, set up a very rigorous pipeline, but if I commit something and it passes the tests, it goes into production. In financial organizations I work with, other more regulated organizations are not so happy with that. So continuous delivery says that we should always have this main line of code, this trunk, or maybe several trunks if we're using microservices, but we should be able to deliver at any given time. We should not be merging broken code into the main line, for example. Jez and Dave, I know, they've got some really interesting Twitter chats recently. They're very strict on their definition of continuous integration. If you're not merging code into the main line every day, they argue you're not really doing continuous integration. If you've got long-lived feature branches, you're not really doing continuous integration. I'll let you decide that one. I have my opinions, and I think there's always a trade-off. That's part of our life as architects, weighing up the trade-offs. But continuous delivery is about, at any moment, we should, in theory, be able to push our code into production and offer value to users. That's the pitch. Maybe we have a human in the loop pressing the button, but it should be good to go at any given time. I think, and we are not all unicorns, we're not all Facebook, Google, Netflix, for example, but the general market, generally speaking, is looking these days for velocity and stability. I want to go faster than my competitors. If you're a Netflix or Spotify, you're out competing, getting new features to market, but we don't want to fall over. We don't want to get breached in terms of security, and we're seeing more and more of these things with security, so I'll talk quite a bit about security. Now, a friend of mine from London, Steve Smith, says, I like this a lot, continuous delivery is achieved when stability and speed can satisfy business demand. Yeah, I like that a lot. Basically, what he's saying is your context, and you know your context far better than I do, whatever your context and your definitions of stability and speed, if you can satisfy them, you're effectively doing continuous delivery. I've seen some people that sort of try and implement a continuous delivery pipeline, check all the right boxes, but they don't have the speed or stability required. And they're not really doing continuous delivery. They've got the mechanics there, but they're not following the kind of core goals. And other times I've gone into organizations and they've kind of got the stability and speed, and all they just need is a few sort of tweaks around putting it in a more formal automated process. Yeah. So this I like. I mean, I'm sure a lot of you recognize discontinuous delivery occurs when stability and speed are insufficient for your context. Yeah. And Steve writes a lot of cool stuff, so follow Steve on Twitter. He's a very interesting chap. Don't think this is too controversial, but creation of a build pipeline is mandatory for continuous delivery. And what I'm considering as a build pipeline is a series of automated steps that are new change, and change can be config changes, can be code changes, third-party supplier coming, introducing a component. Any change should be pushed through a pipeline, and the job of the pipeline is to pummel that new change and prove it's ready for production, or it's not ready for production. Yeah. So this is a Java-themed pipeline. Apologies, a couple of slides will be Java-themed because that's my main language. But typically, I'm coding on my local machine. I'm using, say, Git or something like that. I'm pushing to GitHub, Bitbucket, take your pick. I'm using a build tool like Jenkins or Circle CI, that kind of thing. I'm then building an artifact. Push it to a repo. I use Nexus quite a bit in the Java world, but some kind of centralized repo. I pull that down, that artifact I've built. I deploy it onto QA. Got some automated quality assurance going on, some functional, some system quality stuff going on there. If it passes the QA, maybe some manual stuff, we then push it through to staging, say, as an example. There can be many stages or very few. Staging is perhaps more realistic. QA, I might be using mocks and stubs for third-party testing. In staging, I may be using sandboxes. So when I'm integrating, say, with PayPal, something like that, often we'll stub and mock PayPal in our tests sort of here, but we'll use the PayPal sandbox in a staging environment, make it more real. And then, of course, we push it through to production. and then it's adding value to the users. Yeah, that's the idea. Now, continuous delivery does not end here. In fact, continuous delivery just starts here. The most important part of continuous delivery is this feedback cycle. Yeah? Was our initial business hypothesis proved? How can we improve the business, the architecture, and the operational qualities? We try and go in this loop as fast as we can. I'll show that in a second. But this is what continuous delivery is. Computers are really good at doing sort of the boring regression, automated testing stuff. We as humans are much better at doing the creative stuff, the contextual stuff. So whenever we learn something, like I made a whole bunch of mistakes a couple of years ago around system quality attributes. And every time we learned something, we created a test for it and we put it in the pipeline. So I, or my team, or someone else who was following me, wouldn't make the same mistake. Yeah? And we're even seeing this now in post-production. Rebecca hinted at it this morning, things like chaos engineering. Chaos engineering is really a way to codify architectural properties, codify system quality attributes. If we say our system is robust, then if we suddenly kill off half of our instances running in production, it should be able to withstand that. They should get spun up and it should recover, these kind of things. So we need ways to codify our functional requirements, our system quality attributes, these kind of things. Stability is primarily what I'm going to talk about today is architectural qualities, and Docker containers doesn't really have much impact here, but I'll touch on it because we are at SATURN, of course. But also things like performance. I've seen a bunch of challenges with containerizing applications and the impact that has on performance, and also SOAP testing. So we'll cover some of that as well. And finally, I've mentioned it several times already, for me, more and more security is becoming something to be aware of. I don't know, I won't hazard a guess actually, but there is a split between companies I go into across the US, UK and Germany, where some of them are really good at security stuff, and a whole bunch of others don't even think about security. And it kind of shocks me sometimes, so we'll talk about some of that stuff as well. The speed thing basically is, can I push stuff down the pipeline as fast as possible? Can I augment the pipeline to get all my learnings as fast as possible? That's the kind of speed bit. And that comes back to Steve's pitch. If we've got speed and we've got stability for our context, we are good to go. Move on to the next challenge. Look at perhaps some legacy code, for example. So the impact of containers on CD. So just a level set, container technology is fundamentally, it's been around for quite some time. I think people from Google, some of the initial work, and Solaris jails, and a whole bunch of other technology it's come from. BSD jails, and Solaris zones. These have been around for quite a bit of time. Fundamentally, it is OS level virtualization, operating system level virtualization. Now, I'm sure many of us are used to hardware level virtualization. So Zen, KVM, anything in the cloud, hardware. Anyone who's using .NET or Java is used to an application VM, so the JVM, the CLR, that kind of thing. This kind of sits in the middle. It's an OS level. It gives you some level of isolation. There's a couple of new products coming out now that sort of offer even more alternatives. It doesn't give you quite as much isolation as pure hardware virtualization. But this is fundamentally it. It's control groups, or C groups. They control CPU, memory, network performance, I/O, that kind of stuff. You can basically run something in a container and use control groups to specify how much CPU, how much RAM it can get. Namespaces are just like XML namespaces. We are namespacing things. So we namespace processes, we namespace the network. We can have multiple containers running on the same host, and they won't interfere with each other because they're in different namespaces. Something to bear in mind is that the beauty of containers is it's very lightweight virtualization compared to hardware virtualization. And it does that by sharing the operating system kernel, the Linux kernel, the Windows kernel. And that comes with many advantages, very fast to spin things up. But it also means that if one container crashes the kernel, it will take down all the other containers on that host. So bear that in mind. It's not full isolation. If the kernel goes down, if you cause a kernel panic, it will panic the rest of the containers on that host. That's why we need to run multiple hosts with something like Kubernetes or ECS, for example. Also, I'll probably say Docker a few times today, because I've mainly used Docker, Rocket. There's a bunch of other technologies. There's lots of interesting players coming up in the container space now. Microsoft are doing some really good work. I like Microsoft stuff a lot, actually. They've got a second mover advantage, both in cloud and in containers, I think. So they're looking at Amazon, they're looking at Docker, and making our lives as developers and architects quite easy compared to some of the Amazon experiences. But fundamentally, if I'm using Docker, say, it is a way to package and execute software. I can package my Go application in a container image, and I can run that image. Basically, it's a set of Linux processes, but I can run it with some degree of isolation. The container image is our single binary. Yeah? So what we want to do all our tests on is that container image. Put the application inside, run our tests there. How do containers alter the pipeline? So this is our earlier pipeline. I think it's kind of in like 4 places I've got there. Fundamentally, I might be developing in a container locally. I might be using Docker on my local machine, for example, or containers. I'm now not going to be storing maybe language artifacts. I'm going to be storing container images. So my registry of artifacts probably, where I'm doing all my governance and my security checks probably changes a little bit. 3, the way I maybe do testing now is going to involve spinning up containers. And clearly, the way I'm running the applications will change. No longer am I deploying an application on perhaps, bare metal, on-prem or whatever. I'm probably going to be layering in some form of orchestrator or some form of scheduler like Kubernetes, like ECS. I've used Mesos and used a bunch of them, because they provide a lot of the advantages of being able to shift containers around for efficiency. They give you fault tolerance. If a node crashes, they'll spin up the images that have died on another container. We don't want to be coding this stuff. Kubernetes is a fantastic bit of kit. Now, I do get pushback in some particularly more traditional organizations. When I start talking about things like Kubernetes and ECS, there is a lot of tools, a lot of platforms, and I apologize today that I will talk about a few of them, but it's kind of, it's an emerging area still, so we haven't fully figured it all out yet. There is lots of new tech, but a lot of people say, yeah, this Kubernetes stuff looks a bit complicated. Shouldn't I build my own orchestration system? Shouldn't I build my own container tech? I've even heard before. And my honest answer, and this is a generalization, but it's probably not, unless you're Google, AWS, or IBM. I think now these things are becoming commodities, and therefore I like to rely on commodity suppliers. I don't make my own electricity. I go to the commodity supplier in the UK and buy my electricity from them. I think container platforms are becoming somewhat of a commodity, and therefore I'm more than happy to pay a bit of money, or in the case of Kubernetes, it's open source, but I'm more than happy to pay Amazon to run Kubernetes for me. And whatever you do decide, there's often a bit of operational glue needed to kind of assemble these platforms, maybe for service discovery. And we won't touch much on that because that's more of a microservice thing. But whatever you do decide, if you're using something like Terraform or CloudFormation, Ansible, if you're building out these glue components, they should have their own pipeline as well. And do take care on the interaction between your development pipeline and your operation pipeline. I've seen a few companies that have been trying to run so fast building a new platform while they're refactoring or redeploying their applications that they trip over each other as the platform is still shifting while they're trying to deploy applications on top of it. So Keith's book is fantastic. Keith is a thought worker. I'm sure Rebecca knows him well. Really good book that talks a lot about how to work with infrastructure as code. And the good news for us as architects is a lot of our skills are really valuable for new DevOps engineers or whatever we want to call them, but people that are building this stuff out, massive generalization, but a lot of the people I've worked with are amazing skill sets, but they're not software engineers. They're not architects. So we can actually give a lot of value. I learned, a couple of people in my career have been super helpful to me. I learned many operational responsibilities and how to do more Linux-based stuff and that kind of stuff. And in exchange, I kind of taught the ops people about cohesion, coupling, single responsibility, all these kind of things. So it was a really interesting kind of dynamic. But this is a fantastic book to get you started. I mentioned microservices once, sort of on this final bit of this intro. And the fundamental thing now is you're going to be having multiple pipelines. With microservices, it is no longer one thing. Typically, it's a lot of companies I work with, and Paolo mentioned this yesterday in his company. When they start embracing microservices, it almost becomes exponential. Particularly if you make it quite cheap to create microservices, suddenly everyone's creating them, for better or worse sometimes. So you need a pipeline per service. The kind of goal often is independent service deployment. That can be hard sometimes. I know some pipelines I've worked on, we actually all integrated onto a single pipeline and did a gated release, sort of there, effectively rubber stamping, say 3 versions of services into a version here before releasing, that kind of thing. The biggest challenge with this pipeline, and again, I'm not going to go into it in this talk, I'll link to another one, is breaking the schema, breaking the contracts, the interactions between components. I can change my API and break a service I didn't even know existed. Yeah? And I see a lot of this kind of stuff. It's the classic meme, worked fine in dev, ops problem now. But what I've even seen pushback on this one now, in the development teams are saying, hey, I'm testing locally and it's fine, yeah? But test all pass in dev, architect's problem now. I think it's your problem to work out the integration. I'm like, you're kind of missing the point, yeah? But I get it, it is challenging. This kind of pitch of independent deployment is very powerful, but we must all be aligned and incentivized the correct way. Otherwise, it does actually lead, ironically, to silos. But not silos based horizontally, vertical silos now, business silos, which is quite funny I've seen. But I've got a talk called Continuous Delivery Patterns for Modern Architectures. I actually did that one in Austin last week. I've been over in the US now for a couple of weeks. I was at Deliver Agile, and that one goes into more detail on this kind of stuff, using consumer-driven contracts, using service virtualization, that kind of stuff. I'll take a pause there. So that's the setup in now, and I'm going to basically walk through the pipeline and sort of talk about my learnings, my mistakes along each way. Has anyone got any questions up until now on what you've seen so far? Julie.
Those unit tests, they run inside a container as well? Is that...
Great question, that one's coming soon. Yeah, I've got a whole slide on that one. Yeah. Just to phrase the question, it's do we run unit tests inside the container, for example? I think I'll press on in that case. Cool. So working locally, I think this goes almost without containers, but what I do encourage developers to make their development environment as production-like as possible. Yeah? And if we know we're going to be running containers in production, this means some degree of working locally with containers. Just to understand them, downloading Docker for Mac, downloading Rocket and playing around with it. Often if I'm coding, to be honest, particularly with Java, more heavyweight frameworks, I actually just code normally, and when I've completed an iteration, a feature, I'll then package it in a container and test it locally. But some of my friends who work in Python, they actually run everything in a container and they mount a directory with their code into the container directly. And they run their unit tests in the container. They basically sort of treat that as a web application server type thing. You can do hot reloads. There's a bunch of technology out there which I'll show you to do that kind of stuff. It just depends on what you're most comfortable with, what your dev team is most comfortable with. But the key thing is you must really build or test containers locally. I've seen a few organizations try to ship code in containers and not even expose container technology to the developers. But I'm a big fan of something called mechanical sympathy. Yeah? I want to know at least one level down from where I'm working. So as a developer, I want to know the fabric I'm deploying onto, because that probably alters the way I code. If I know everything is going over the network, a la cloud, I'm going to code more defensively in terms of communication than if everything's going to be an in-process call. So I think getting developers playing with containers locally, performing happy path tests locally is really good. What I would stress as well is using identical base images from production. So when you now package an artifact in a container, you're sharing the kernel, but you're bringing in a new operating system, potentially. You can share the kernel, you can be running CentOS on the host and Ubuntu in the container if you want, for example. You are sharing the kernel. But what I've seen some people do is their security team have basically verified, say, CentOS for running in production. They only run CentOS in production. But all the developers are more comfortable with Ubuntu, and they're running Ubuntu locally in the containers. And there is subtle differences between distros. Yeah? What works in Ubuntu doesn't necessarily work in CentOS. Particularly if you're using things like SE Linux and AppArmor, if you're doing more security-conscious stuff, you really need to make sure what you're using to run your local tests and do your local development is the same as what is running in production. Yeah? And I'll look at that in just a second a bit more. But a quick digression. So one thing I've often had people struggle with is particularly with microservice systems, they cannot get all the components running on their laptop, on their Mac. Particularly in Java. Java's a bit memory hungry still. So my Mac's got 16 gigs, but I can only get, say, 4 services, reliably running on it at a time. So I talked about this actually in 2015. Some of the challenges, I was working on a project in the UK. It's like NOFS, it's called Not on High Street, kind of like a UK version of Etsy at the time. And we made a bunch of mistakes on these things, and we were trying, as the system got bigger, we were really struggling to set up sort of all the components we needed. Not even the whole system sometimes. We just wanted to set up a few components to sort of test them or to run integration tests. We could push it to the cloud, and the cloud would run it all fine, but locally it was quite a challenge. So you can have a look at the blog post. I've sort of talked about a few patterns my team came up with, and really interesting stuff. And one of these patterns was called environment leasing at the bottom. And I'm seeing this pattern more and more now, where you actually deploy everything you want, and it can even be a full environment sometimes, to a remote environment. So you effectively spin up your own Kubernetes cluster. You spin up your own Mesos cluster. And not on High Street, we were using Mesos, and we built the ability so that in Jenkins, anyone on the team, developer, QA, business person, could spin up an on-demand Mesos cluster. It was all using Terraform and Ansible. It took about 15 minutes to build, but they pressed the button in Jenkins, they selected their services they want deployed into that environment, and 15 minutes later it dropped them an email and said, hey, QA 157 is now ready for you, purely isolated on demand, and they could go and do their QA, for example. Or as developers, they could then basically proxy their local machine into the cluster. So you're developing locally as if you're in the cluster. Comes with disadvantages, but one of the companies I'm working with, DataWire, we've got an open source tool called Telepresence, and there's a couple other ones like it, Casync and a few other ones as well. This is becoming more and more of a popular pattern now, where effectively I can put my laptop in the cluster. It's just proxying to be honest, but I can swap out my actual service I'm working on with a proxy. Telepresence locally will basically proxy in, and I can run my machine, I can look for environment variables, I can do digs on the network and all these kind of things. It is in effect that my machine is actually running in the cluster. And I can run, providing I've got a crazy big kind of, environment here, I can now run my everything bar the one service I'm working on, or the 2 services I'm working on locally. Locally I can be debugging away, doing all the stuff I'm used to doing, running a local debugger, because debugging microservices can be really hard, particularly if multiple ones are involved. But this is a nice pattern. So if you're struggling working locally, check out Telepresence, check out Casync, there's a bunch of other ones, the blog post goes into a bit more detail. It's an interesting pattern for QA or for developers if they're struggling running everything on the laptop. Kind of a bit of a thin client type thing, perhaps. So going back to this one anyway, so definitely use identical base images. If you're running CentOS in production, run CentOS. One of the lessons I learned is that the Dockerfile content is super important. So Dockerfile is basically a manifest, effectively. It says what image we're basing from. So this is a Java example. We are starting with a base image that has the OpenJDK Java runtime environment. I'm adding an artifact that I've built into this directory. I'm exposing some ports, and then this is my run command for the Java app. Now, there's quite a lot of things going on here, particularly for developers that are not operationally aware. And I have learned a whole bunch over the last few years here. Suddenly, someone says to you, oh, choose your OS. And if you're a developer and you've never really done much on Linux and stuff, you're like, what? That's a hard choice. You can also use Scratch containers. You can use distro-less containers. There's a whole bunch of things. I'll run through some of the options in a minute. But there's also configuration going on there. There's build artifacts being put in. I'm exposing a port. So here I'm not even defining a user being run, which is a potential security issue. If I'm running Java, do I put a JDK or a JRE in there? What JDK do I use? With Go, do I statically compile the binaries? Do I put everything I need into the binary and run it just very simple, kind of full-fat binary, or do I not? If I'm running Python, is there any need to run virtualenv now? Because I've got the container giving me some degree of isolation. When I first started playing around with Docker properly, this is a bit bewildering, if I'm honest, yeah? Many dev teams do struggle with these things. And what I learned is when doing migration projects, is basically talk to the sysadmin people as early as possible. Talk to the InfoSec team as early as possible. Their knowledge is super, super invaluable. I think a lot of companies look at QA as kind of gatekeepers, look at InfoSec as gatekeepers, but you have to bring them into the process early. If you're bringing in cloud, you're bringing in containers, there is a whole lot of potential fear that can go with that, yeah? So, as a developer, I learned to, one of my first things when people calling me in for migrations, I'm like, are InfoSec involved? Are the ops team involved? And if they weren't, we brought them in. Because they could often help us answer all these questions. Oh yeah, we run CentOS, we use SE Linux, we've got a license for this, license for that, and they give us all this advice. But with Docker, it's the old cliche, with great power comes great responsibility. Yeah, I think. So another aspect I see, going off on sort of some of the unit testing thing, is you can run the unit test quite simply. There's an awesome lady, what's she called? Ryan Wine on Twitter. Laura, okay, it's Laura. Awesome blog post which I can share where she's talked about running Ruby unit tests in containers versus not. So she's gone into a lot of detail on that. But one pattern I do see, or almost an anti-pattern, is that people have different containers. So they build their Dockerfile differently for dev and test versus production. So they have this full-fat kind of container with all the tools they want, maybe some pre-canned data, all these kind of things. And full OS, full Java development kit, these things. And I get it, because as developers and architects, when we're playing around with code, we often like our tools. We like our certain comfort. But then the problem is, if you're having these two different types of containers, like a slimmed-down production one, it's easy to see configuration drift between our dev containers and our production containers. I actually like using something called the test sidecar pattern instead. And what this is, and Alexi's done a great blog post here, but what this effectively is we create early on the container image that is going to be running in production. It might be super lightweight, it probably should be, because we're minimizing the security attack surface, we're minimizing the performance overheads, for example, by making everything small. But we create this sidecar container, and the sidecar, all it is another container that we can run by the side of the other container and do tests. And our sidecar container contains maybe some pre-canned data, contains some stubs and mocks, service virtualization stuff. It maybe contains some of the testing tools that actually run the tests on the real container. Yeah. So you hear a lot about sidecars. If you're in the container space, there's something called service meshes, very popular at the moment. I'm not going to touch much on that today, but this notion of a sidecar is becoming a very popular pattern. But all it means is like a motorcycle sidecar. It's literally a separate container running alongside the container, and we have this artifact we're going to deploy into production, and then we have the sidecar container that is orchestrating the tests on that container. There's a link there for that one. Something sort of closely related, there's something called Docker multistage builds, and this is quite a useful tool sometimes. We can actually, this is a sort of Dockerfile, but it's subtly different in that you can actually have a builder definition all in one file, but then have a runtime definition. So if you do want to chuck some tests and some additional stuff up here, you can, but by keeping it all in the same file, you're less likely to see the drift. It's easier to audit what's going on. And you can actually do all the building, like in this sort of the builder image here, for example, and I think I've got an arrow going down. You can so here we've got like this is a Golang example. It's quite a rich container we're using to build our Go binary, but then we're shipping it in a very lightweight Alpine container. And we're saying copy from the builder, copy from this bit of the build into here and run it like so. This is quite a nice pattern, sort of keeping everything a bit consistent, but having perhaps multiple steps in your Dockerfile. I mentioned earlier on about distroless Docker images. So it's advantageous to not put too much in your container. Yeah. So we want to run as little amount of OS in our container for performance reasons, because the more operating system we've got in our container, the more resources that takes away from our application, and also the bigger security attack surface. Might be some heartbleed in there, might be some other bug in there, for example. So Google Cloud Platform have created this thing called distroless Docker images, and it's basically just enough operating system to run all these languages. They've got Python, Node, Java, Jetty, .NET. They're not full OSs. There's no package manager in there, for example. But they're just enough sort of components to run the applications. So this is a way of minimizing performance impact, minimizing security attack surface. Rather than using what you're perhaps comfortable with, Ubuntu, CentOS, you can use these stripped down versions, if InfoSec are cool with that. I'll take a pause again. So that's, we're going to move now on to building artifacts. But any questions up until there? Pavel.
So you mentioned about the container image across from development all the way to production. Are you going to talk about tagging them?
That one's coming up in a minute, yes. Yeah. Wait, tagging me in a second.
And how to properly?
Yeah, so I made a bunch of mistakes there, so I'll definitely share a few of those. Yeah. Hopefully that will go into enough depth. I appreciate this is probably quite a lot of stuff. How are people finding it? Is it going okay? Hopefully it's a bit of a spit in the audience, but yeah.
Is the sidecar different than a different Docker layer? Is it like a different Docker image completely that then needs to, you need to like compose?
Yeah, interesting question. So what's the kind of difference between, say, layers within Docker containers, because you can kind of layer up, or is it a separate Docker container? And the answer is it's a separate Docker container. So what I've often done is I've got my lightweight kind of container that I'm going to run in production. So it's just got my app and very minimal OS in there. But I've got this other container that maybe contains Ubuntu or something with all my dev tools in there. Maybe it's got some like a in-memory database like MySQL running in there, which I can then kind of use to test and various things. But it's a completely separate image. I can do whatever I like in that test sidecar because that one will never go into production. It's purely a development tool. I stuff all my tools in there, I can do my tests and whatever, but the only thing that goes into production is the image containing the very lightweight and stuff.
Okay, thank you.
Cool.
And the idea would be to mount the volume of the production image into the sidecar, and that way you can test it, or? Yeah, so you can do a bunch of different ways. I won't go into loads of detail here because I'll even struggle on some of this stuff, but yeah, you can do many different things. You can link the containers in Docker, in terms of I've done that a bunch of times. You can mount directories off host to share directories. Alexi goes into it in quite a bit of depth in the article, but it's a good question. The main sort of thing, pattern I'd like to share is definitely don't chuck it all in one image. Because I've gone to some companies where I look at their Docker containers running in production, and it's got Ubuntu with a full Java development kit and all these ports open. I'm like, oh my God, that is a massive security vulnerability. We need to get that out of production as soon as possible. So my main sort of pitch is run it small, but there's a million different ways and you can link them together. Cool. So this one is actually quite a short session, the building artifacts, because it is very specific to the technology you're choosing. If you go on Amazon, ECS for example, Amazon people have got great documentation. They'll go into a lot of this in a lot more detail. So the report I've written, the little mini book, goes into this in more detail. There's an example I use there, Docker, just pure Docker and Docker Compose and Jenkins. But it gets a bit nuanced. I've done a bunch of work with Apache Mesos, a bunch of work with Kubernetes, a little bit with ECS, and to be honest, it's just technical details. So you check out the report if you want to know more details on that. One of the questions to ask yourself is, do you want to build the images in the cluster? I've seen a few companies struggle with this. I actually like having, say, a separate build service, either Jenkins or something running outside, or I've used Circle CI. I've used SaaS products to do my container building. I find that more cost effective, to be honest, to use SaaS products in this way, and it eliminates the headache. If you're trying to build a container image within something that is already running in Docker or in a container, it gets a bit like that film Inception. You're running Docker, in Docker, in Docker, in Docker, and you're like, where am I, kind of thing. And I like the film Inception, but it got confusing, yeah, the same kind of deal here. So I actually lean towards running my development and build process outside of the cluster, and then just using some kind of build server or some kind of tool like Rundeck maybe to trigger the deployment of something that I've put in a registry. So my SaaS product builds the image, puts it in a registry, and then I use something to pull the image from the registry and run it QA or whatever. Increasingly though, we are seeing tools that allow you to build in the cluster. Google are doing a lot of work on this. There's Canico, and that gets around this whole inception problem. There's Jenkins-X, so I'm a big fan of Jenkins. It's the sort of, the least worst build tool, I think. I've got a lot of love-hate for Jenkins. But there's Jenkins-X, where you can actually run a full build server in Kubernetes now. And it can build images for you, and you can store it, say, in a registry within Kubernetes, and these kind of things. So I wrote up some stuff, actually I write for InfoQ, I wrote up some sort of thoughts on this. Definitely a pattern to consider is, are we going to go all in on the container, or containers, all in on Kubernetes, or are we going to start some of our tooling outside the cluster, and then perhaps move it in? Definitely one question to ask. For deployment, again, not going to cover this because this is a very emerging space. I'm sure a few of you, if you're using containers, I figured the actual development experience is a bit kludgy at times. I'm building my Python app, then I have to build a Docker container, and I run my tests on that, and then I sort of deploy that image. It all gets a bit clumsy at times. And there is a bunch of frameworks that are coming up now to automate a lot of that process. So Draft, Ksonet, a bunch of other things, Scaffold by Google, they're effectively development workflow tools. So they give kind of strong guide rails on how to package your applications. So Helm is effectively a sort of a packaging format that wraps Docker containers and other things. It's an even sort of as a meta wrapper. And this is very much an emerging space. So I think it's going to, by probably a year's time, it's probably going to become a lot clearer. But at the moment, definitely check these things out. Again, if you're with a cloud provider, they often give you a sort of a well-trodden path. Amazon, Google, Azure, they will recommend how to sort of do development and deployment and so forth. And I often follow their advice if I'm on their platform, to be honest. The kind of true open source way of packaging and deploying and how my development workflow goes from machine to cluster is still an emerging space, and there's a bunch of sort of references I put there. The Scaffold, you can run some stuff locally and then you can push it to the cluster. Some of them encourage doing all of it in the cluster, as I've sort of hinted at with some of the other tools earlier. But this is kind of a very emerging space, but it's something, even as architects, we need to pay attention to. The developer experience for cloud and containers is really important. Because if you suddenly introduce a whole bunch of friction into the development lifecycle, it can get confusing really fast. No longer are you just, putting your application in a container or whatever, you're now asking developers to use a whole bunch of different tools locally. So, bit of a red flag. It does depend very much on what fabric you're using, so that depends. Pause there on that one. Now we're going to look on to the metadata stuff as well. Any questions up till this point?
You mentioned CloudB is a Jenkins plugin for building images. That's an option to just opening a script and doing a Docker build.
Yeah, so the CloudB plugin is really nice actually, and it basically automates a lot of that stuff. Under the hood, it often is doing Docker build and all these kind of things. But it's a nice plugin. Most of the other build tools like Concourse, Circle CI, and a bunch of other ones, they offer the same kind of stuff. It's effectively a nice wrapper for doing a lot of the kind of stuff that's very manual in terms of Docker build, Docker tag, Docker push, all that kind of stuff. So I've used CloudBees. The CloudBees are the commercial arm of Jenkins. They sort of look after Jenkins. And I've used, it's open source, that's all. I've used that quite a bit. I quite like that. But there is a Kubernetes plugin for Jenkins. We've done ECS deployment via Circle CI and a bunch of other stuff as well. So metadata, this is, for me, is key to unlocking many things. And a lot of perhaps the key takeaways are almost they're relative to whether you're using containers or not. But for me, like I asked at the beginning of the talk, we as architects, we as operations people, maybe as developers, we should be able to know what is running in production, or we should be able to find out very easily. And generalizing and obviously anecdotal experience, but when I go into companies, I ask, what version are you running in production of your operating system? What version of the application are you running? It does often create a bit of a panic as people run around and go, you know what, I've got no idea. So this notion of metadata on all the things we build is actually really important, particularly for governance, for provenance, for security, many things. And Docker, or container, sorry, not Docker, and I'm using them interchangeably, but container technology adds like another layer. No longer do I have to worry just about my artifact and the OS, but I'm now putting that artifact in a container and I'm deploying onto a fabric like Kubernetes or whatever. So there's even more things in the mix now to be conscious of. So just before going into more detail, but something you mentioned, Paolo, there, so one of the things I've been burnt on is there's this notion of the latest tag in Docker. If you build something, and I've seen a lot of people create CI systems where they always deploy the latest version of their container, which kind of makes sense. Off the top of your head, I've built something, I'm doing it in CI, always the latest version being deployed. Great blog post here that proves that is a really bad idea, because latest actually means it's the last build or tag that ran without a specific tag or version. So I saw some people doing some stuff by CI, they manually intervened for a hotfix and completely destroyed the meaning of latest. And they were confused of what was running in production, everyone was super confused. So as sort of Paolo hinted at, I recommend using semantic versioning, semver, yeah, so major, minor, patch kind of stuff. And basically tag all your images with, you know, that's my username on Docker Hub, and then, you know, test is a container name, but I'm tagging it with a semantic version. Then you can also use things like the actual git sharp, you can put that in metadata, which we'll talk about in a second, then when you can, you know, look at your metadata archives, you can say, I know exactly what is running in production here. I know what the contents of these things are. You can add even more data into the container, more metadata, using something called Docker labels. And it simply is key value data that is stored into the image. So you can use, you know, you can do kind of quite fancy namespaces. You can put, you know, built by, it was, you know, QA audited, for example, these kind of things. So using labels is very powerful in Docker. There's a nice, it's by Ross from Microscaling. He's created a makefile, I think I've got it on here. Yeah, so he's created an example. Let's say you might use labels, you put, say, you know, the vendor of the container, various different metadata. And he's created a nice makefile that you can run in CI, and it takes, you know, the current date from the operating system, takes the user, basically transposes a lot of interesting data into labels automatically. So you kind of get all, you know, the git sharp goes into the Docker container. When we crack open the container, we can see what code exactly was in there. So kudos to Ross there. There's a bit more information about how he was using, how the team was using labels in the containers to add metadata. That's quite nice. One thing I've often wanted to do is add metadata after I've built an image. Yeah, so I've built an image, I've run it through QA, run it through security verification. We effectively want to stamp on that image that it's been verified. I've done my QA. You can do this, unfortunately. You can run a Docker image, you can run a Docker container, and you can add a label at runtime. As soon as the container terminates, you lose the label. Yeah. But you can Docker commit, you can Docker run, add the label, Docker commit, but that effectively creates a new layer, a new image. And that kind of breaks my, you know, single binary type thing. So I don't like doing that. There's an open proposal on the Docker repo where they're discussing should we be able to, you know, dynamically add metadata, add labels to containers. What I've actually ended up doing is often using registry or repo technology like JFrog or like Nexus, where I upload my Docker image to them. There's open source and commercial offerings. Often use the commercial offerings, they do offer a lot more support. But I can then add metadata to the image as the image moves down through the pipeline. REST APIs, you can call it the REST API, you can say this container passed security, this container passed tests, these kind of things. And then you do, when you deploy, you make sure you're checking, is there metadata for when it was built, when it was tested. If there's not metadata, in your script, you halt the deploy and you create an alert, these kind of things. That's how I've done it. So this is the only bit of the talk where I'm talking about stuff I haven't really done at all actually in production. Yeah. So but I thought it was so interesting to mention because it does seem like the way that the technology is going. So there's a tool by open source tool by Google called Graphius. And it's basically a metadata API focused towards containers. And they've also got a tool called Critus that does that verification that I mentioned. So the pitch in sort of Graphius is there's a standard kind of guideline of how we can, you know, make assertions on containers. and we can cryptographically sign them. And then things like Critus can, when we're trying to deploy an image, we can check for the presence of cryptographically signed attestations or assertions, and only deploy if we see those attestations with the right signature, these kind of things. This is super beta. Graph.js is being like talking. You can jump onto they've got a Gitter and a Slack and stuff. You can jump on and chat about this thing. I think it's super interesting. Critus, there is a beta or an alpha version available in GKE, and GKE is Google's hosted Kubernetes service. So that's the way they're pitching kind of to do these things. I'll run through some of the details in a second. Shopify has done a lot of good work in this space. They are using the beta version of Critus, or Critus, what's it called? Critus, yeah, and Graph.js. So again, I'm playing around with this stuff. A few clients are interested. We haven't used it properly yet. I think it's interesting. Like the weekend, actually, I wrote up my findings so far on some of this stuff on InfoQ. So the link's there for you if you want to check that out. But they're effectively defining not only container images and all these kind of things, but they're also trying to work with a bunch of people in the industry around defining security alerts. So that people could, say, feed in various metadata into your pipeline and say, hey, we know you're running Debian 8.2 and it's got this vulnerability. And then you could do an automatic audit of what was running in production, all these kind of things. So it's a very nice kind of way. And I've seen some examples online already, and apologies for the eye test, but this is kind of like a way they're signing what they're building in a container. And this was actually, I think, from SNCC or one of the companies where this is a schema for reporting CVEs, common vulnerabilities and exploits. So again, this is just stuff to sort of be aware of. The most interesting thing is the attestation I mentioned before. It's a way, basically, and this is Google's diagram I've borrowed. You'll recognize the pipeline, kind of similar to mine at the top. They're obviously looking to deploy into Kubernetes. I think I've got that there. But you're building, you're working, testing, you're deploying, and this is their GKE or app engine over here. So Graph.js is sitting down here. There's the metadata, it's sort of the repository of metadata. And as we're building, we basically are writing these sort of predefined payloads, and we're signing them with a key. We're saying, for example, this is built by us. We know we built this image, and we're signing it with our key, our public key. We know, for example, we've tested it, and we're signing it with our public key. And we write those to Graph.js. When we come to deploy, and this works in the Google, it's called binauth, I think binauths in Google and GKE. When we come to deploy, it basically looks into, when we come to deploy, we can define a policy. And the policy says, this attestation, it must be built by us and tested. Yeah? Then when we go to deploy, it looks into Graph.js and sees, have we built it ourselves? Is there API data, is there metadata here that says we built it, we tested it, and if so, then it gets deployed. If it's not there, or we didn't sign the attestation, it doesn't get deployed. So this is, I'm sure a few of you have seen this. This is not a new pattern, and many of us have done this with other technologies. But for a while with containers, we didn't really have this kind of approach. So Google, to their credit, are realizing this and producing these tools just to keep an eye on that are going to give us hopefully some more kind of governance in our software supply chain, knowing what's going through into production. And if suddenly a massive vulnerability is discovered in the Linux kernel, we should be able to look into Graph.js and say, hey, we are not running that kernel in production. We are not running that OS in production or whatever. So this metadata API and using it as a kind of gateway is an interesting pattern. Pause on that one. So I'm going to look at some QA now. Any questions at all on that one?
I had a question. What I'm understanding is that when you finally deliver to the production, there's multiple containers. Okay, so when you're doing all this goes, so you're focusing on one container at a time?
Oh, great question. Typically, yes. Particularly for things like security, for quality attributes, we're definitely focusing on one container. You also want to, and I'll mention a few tools in a minute, you do want to focus on the overall platform as well. But in terms of functional requirements, you do often focus on individual to start with, but then you gradually go up through in terms of integrating a few components and then maybe doing some tests on the whole thing. But I think sort of in the direct answer to the question would be typically with these kind of things, yes, you're focusing on a single container.
Okay.
we deploy our applications on containers in a cluster, the container gets moved within the cluster from one system to other system. There's more load in one system. There are a variety of things happening, right?
Yeah.
So for all of these quality concerns, should we worry about how containers operate within the cluster? Or?
Well, that's an interesting question. So paraphrasing it, should we worry about the way sort of the platform, the fabric we're using to run, Kubernetes or whatever, excuse me, does that impact? So I definitely recommend testing on as like a production system as possible, but I think there's only some degree of certainty you can go for, because we are definitely moving from complicated systems to complex systems with this whole, there's a lot more moving parts, almost emergent behavior sometimes. So I don't think you could test all of the problem space, if that makes sense.
You've got to trust your...
Yeah, but you definitely want to, and I'll mention some tools in a minute for test. You want to test things in, you sort of build up confidence. You test the container, then you test it perhaps like integrated with a few other components, maybe do a load test, and then you might do some synthetic transactions in production or something. And there's always observability and monitoring going on. So I often say, the level of comfort we need, and then we also monitor and alert in production. Because there's always stuff that pops up I never would have thought of. I catch it with my monitoring in production, then I create a test to prove that doesn't happen again. Yeah. That's an interesting question. Right, I think I'll press on. We've got 30 minutes left. QA, so forth. Multi kind of level on this one. So you can start with validating container structure. Yeah, you can actually, there's a tool called Container Structure Test. I think it's another Google tool. Google's repo on their container technology is fantastic. It's got so many tools, don't even talk about half of them for some reason. But if anyone's used things like Knife in Kitchen in the chef world, or things like that, you can basically declaratively make assertions about the container image. Yeah. So it runs like there's a nice readme, but you can create a YAML file that says, if we run this command in the container, we spin up the container, we run a command, do we get the expected output? Are we gUnicorn? Is gUnicorn running? Is it in the right location within our file system? You can also say, does this file exist within the container? Things like, what's this one? This is environment variables, I think, and various things like that. Yeah, test. You can basically make lots of declarative tests against the structure of the container. This is particularly useful if you do want to separate your dev and your, say, SecOps, that kind of stuff. The SecOps can say, I always want this security system running in the container. I always want a non-root user in the container. I always want these properties. And developers can create their containers, but part of the pipeline runs this structure test, and it basically makes key assertions. What I would take care of, like many of these tools I've used in the past, is because the definition of a Docker image is quite declarative by nature anyway, you can almost end up duplicating the world. So you're saying, copy artifact from A to B and run with this user. And the test literally says, has it copied from A to B? Are you running this user? So be careful. I've definitely made a bunch of mistakes on this one. There is core use cases, particularly around security here. Are we running certain users? Are we running certain security tools, that kind of stuff? But take care on not sort of creating another model of the world, effectively. What I like to say is a little story related to this is when I first discovered mocking technology, so I used I think it was EasyMock back in the day, I had a real problem because I mocked everything. And then what I actually had is I had my business problem model, I had my code version of that model, how I tried to code the business problem, and I had the mocks that were a model of my thinking of the business model. So I had three models. When the business model changed, I changed my code, I'd also have to change all the mocks. Completely my fault, I'm a bit crazy on that. And it's the same here. I've seen people get super test focused, which is, I encourage, but they almost end up recreating exactly what they're doing. They've got another model of the world to verify, it can be painful. If you get stuck, so sometimes I've seen these tests fail and I'm wondering why. There's another tool by Google called Container Diff, and it literally does like a git diff, that kind of thing, against the world, and I found that super useful for understanding how I've accidentally put a file in the wrong place, things like that. There's a diff between two different containers. So for functional tests, I'm sure many of you are used to the test pyramid, these kind of things. So you go through your unit tests, and we want probably more unit tests than we do exploratory, but we recognize there's a lot of value in exploratory testing as well as other things. Awesome lady called Cindy Sridharan talks about, as we're moving to these complex systems, like I mentioned, we're running microservices, running serverless, all these kind of buzzwords. There's actually only so much we can guarantee by doing these tests. There's a definite pattern, and Cindy's put it in like a funnel, saying we actually now need to test in production as well as test pre-production. Yeah? And so things like canary and chaos testing, feature flagging, all these things are basically post-deployment testing. Yeah? So you want to have a certain guarantee with pre-prod testing that we're happy to some degree, but we also want to have monitoring, these kind of things that are testing in production as well. Yeah? So you could argue that perhaps the pyramid is more from our monolithic days, maybe our SOA days. These are our kind of SOA 3.0, as you said yesterday, Paolo. So these maybe our model of testing, and again, we as architects are definitely involved in this conversation, maybe our model of testing needs to change. And containers do make this more obvious sometimes as well. So I'll rattle through this. So with component testing, if I want to just say this is a sample architecture, ridiculously simple architecture I've used in my book, if I just want to test, say, one thing, it's not a real world thing, so yeah, typically in the real world I'd have like an API gateway maybe in Nginx, I'd have some databases in the mix and a bunch of other stuff, but if I just wanted to spin up that one container and run some tests on it, I often, in the past I've used Jenkins pipeline as code, and it's just a way, using Jenkins, you can do it in Circle CI, different other tools. There's typically a plugin to run a Docker container. I run the Docker container and I run my tests against the container. Maybe using the sidecar we talked about earlier. Simple as that. Yeah. There's also a lot of, so this is one way, this is Jenkins syntax, I don't worry too much about it, but by now actually, a lot of languages offer the tools built in. So if you're using .NET, you can use .NET to spin up a container and run tests with NUnit, for example. If you're using Java, you can use Groovy or Maven to spin up a container, and you can use all your tools to test the containers. So you can either spin it up using external stuff, and this is just a pattern I've used. The beauty of this pattern is I can run any external process. So I can run security tools against my container running, and run a bunch of other stuff, but I often use the actual Java tools now to spin up a container, run some component tests, purely through the API, just exercising that whole kind of component. Integration testing, so it might be part of my system, might be the whole system. To be honest, I keep it simple again. I use things like Docker Compose, or I use things like Kubernetes YAML to basically define some part of how I'm running it in production and just spin that up and run my tests against it. Yeah, nothing too complicated there. For non-functional tests, for system quality attributes, so testing them in the pipeline, I think, is really important. And I often, so when I'm going into a company, I talk about these three things. I say, are you testing for architecture quality attributes? Are you testing for performance? And are you testing for security? These kind of things as well. And I'm not going to talk much about architecture, but because we are at SATURN, I had to kind of mention it. Why did I think that? But so in terms of architectural visibility, if anyone hasn't read Adam Thornhill's work, I always like to take any opportunity to pitch Adam Thornhill stuff. I don't think Adam is SATURN, but I totally recommend Adam. Your code is a crime scene. What looks like a New York City block there is actually a visual representation of a code base. Yeah. Each block is a module. Each individual sort of bit there is like I think it's a class or a package, a module, and you can do various complexity metrics. So how tall the building is like how much cyclomatic complexity is in that class, for example. And the color is the churn of the module in Git. So Git churn. So not only do you get complexity and size metrics very visually, you also get sort of areas, but these could be problematic areas. They are large areas of the code base, there's individual complex areas, and it's a high churn area in Git. We've all got those bits in our code base here where we're constantly kind of having to fix stuff. Anyway, not too container related, but I also recommend things like Code Climate and SonarQube. I've seen many microservice projects where the first few microservices turn into monoliths over a few months. So get this stuff in early. I think you mentioned it yesterday, Paolo, about it's very easy for microservices to turn into monoliths. Containers, don't make a difference in that, but get these tools in. And you may need also some runtime. I think sometimes my experience with architecture, people will spend a lot of time on the static views and not so much on the dynamic views. And containers make it super easy to be dynamic, to move things around and stuff. But there is APM tooling, monitoring tooling, tracing tooling, which I found really useful for getting a runtime view of my system. I won't actually, I think that's another talk, but I don't know if anyone's bumped into Arch Unit, a really nice way for doing unit testing of your architecture. Sorry, that is actually from another talk, I let that one in. Performance testing, so I'm a big fan of using Gatling. So Gatling is just, it's a Scala-based tool, nice DSL. I can write, hit this endpoint, ramp up this number of users, and do all these tests. I can make basic assertions in Gatling. So I can say, call this URL and I expect this payload, maybe the regex or something. But again, I use say Docker Compose or Kubernetes. I spin up a little node perhaps in the cluster or automatically do a testing. I like Gatling because I can capture traffic in my browser. So I can do tests in my browser and it records in HAR format and I can load that into Gatling. I can also use the Gatling scripts in, I'm going to forget the name, but there's a commercial tool. I've forgotten it now. I've used it. Basically, it takes my Gatling scripts or our Gatling scripts and runs them on Amazon at scale. Hammers your, not Blaze Meter. I didn't used to use Blaze Meter, but it's another load grid or something like that. I can tell you if you're interested afterwards. But I like using this to test locally. I spin up some containers locally and I move it to the cloud and test it as well. The reason, this kind of testing is important is this notion of mechanical sympathy. And this is a Java example, but it also applies to other languages. One project we had a bunch of issues that came up. It was our first big project actually using Java in Docker. And luckily we did a bunch of load testing and stuff and we just spotted all these issues. So one classic example is the JVM, the Java Virtual Machine, pre-Java 8 is not C group aware. Yeah, but the OS enforces the constraints. So I spin up a JVM. So we were using Amazon machines. We had like 64 cores, I think it was, 100, crazy amounts of memory. But the JVM, and we spun up, say, 32 containers. And we said in the C groups, each container gets 2 cores. Yeah? 32 containers, 2 cores each, running on a 64-core machine. Problem was the JVM saw the host. It's not control group aware. And it goes, oh, brilliant, I've got 64 cores. Then the OS will basically, Docker in this case, will limit the actual amount of CPU performance you get. Yeah? But the Java virtual machine, often when it boots up, it says, oh, because I've got 64 cores, I'll create 64 threads for my garbage collection. I'll create 64 threads for X, Y, and Z. The Java virtual machine tunes itself to the hardware it's running on, but it's not always container aware. And it's not just Java, this is my main experience with Java, a bunch of other things as well. The new versions of Java, they've really made an effort. Oracle have totally realized how much this is, Docker is changing the world. So I think we're on Java 10 now, I think it is. It keeps changing, but they are C group aware. But a lot of the old Java, I've seen people do a lift and shift, and it doesn't work as expected, particularly around garbage collection. I've also seen people struggle with memory. So don't forget, if your runtime has a heap, you need to set heap, but also make allowances for other stuff in the container, your OS and native threads and a bunch of things like that. I had a bunch of weird issues where the container was getting killed. The container was getting killed by Linux because it was trying to take too much memory. And we looked at all the data and we were super confused, but we actually set it too tight. We'd said, 2 gigs of memory for this container, but the application was creating a lot of native threads, and each native thread has a certain memory requirement, and it was basically causing the Linux kernel to kill the actual Docker container. Another bizarre one, we had an application that would just lock up randomly. We're load testing it on its own, it was fine. Load testing it in Docker, suddenly it would just lock up. And what actually happened is we were running it on these machines, these big machines in Amazon, there was no entropy, no randomness. Yeah? Because when you're doing a lot of crypto operations, the pseudo-random generator, particularly dev-random, uses entropy from moving the mouse, from the key, network packets, all these kind of things. But when you're running in the cloud, there's not much entropy available, and by default, a lot of platforms will use dev-random to get entropy from the host to do crypto operations, to generate tokens, all these kind of things. And what was happening is we were exhausting the entropy. With our 32 containers all running on this one host in Amazon, we were exhausting the entropy, and the application was just blocking because it was waiting for dev random on the Linux file system. And we had to debug, and we looked at the stack trace, and we figured whenever it froze, it always froze on a session generation event. We generated a new session, and we suddenly realized, entropy issue. And then we actually switched to using urandom. Dev urandom is non-blocking. Now, depending on your perspective, there may be security implications using random versus urandom, but I've put some notes there for someone else's notes, so you can decide for yourself whether, for your context, whether that will be okay or not. Just sort of going through the basics with moving on to security now. I hope many of you are using code scanning. This is from my book, an example, again Java themed, sorry, but we're using sort of static code scanners to pick out obvious stuff like SQL injection. There's a bunch of daft stuff we can very easily do as developers, and in the pipeline you definitely need to check for these things. Dependency scanning, basic code scanning. On that note, highly recommend, are people familiar with OWASP? People bumped into OWASP before? Awesome open consortium. Talk a lot about security. Fantastic resource on top 10 web vulnerabilities. They've got a bunch of language agnostic tools. One of them is the dependency scanner. It supports many languages. This is a Java example, but like 10 lines of code there. What that does is it looks at my dependencies I've brought in, and often with microservices I'm bringing in lots of dependencies. My code's quite small. My libraries, my dependencies are quite big, particularly in Java, in JavaScript as well. This looks at all the versions of my dependencies, phones out to the National Vulnerability Database, and says, do any of the libraries I'm using at that version have any CVEs, common vulnerability exploits? And it does some clever caching and stuff, so it's pretty good in the build. And it reports back if any of my libraries, say a logging library, has got a known CVE in it, you can fail the build. So I ran it on an old project, about 6 months old project, Java project, and it basically came up with 5 components. All of them, some of them more severe than others, but there was 5 CVEs that were known, and all of them had new versions that did not have the CVE in. So I just upgraded my versions. Nice report there, and you can fail the build and all these kind of cool things as well. Now, this, probably more important for our talk is not only do you want to scan your code and scan your dependencies, but you want to scan the container image as well, because you're bringing in that whole OS now. You're bringing in Ubuntu, Alpine, whatever. Potentially you're bringing in Heartbeat. Now there's a bunch of commercial tools you can use, and I've used them and they're very good actually, so I often recommend, again, I'm not shy about using SaaS products that I like, and I'm happy to pay someone else for, for their expertise. So a bunch of tools out there, Docker and Quay or Key from CoreOS do these things, but there's an open source image scanner called Claire from CoreOS. And it basically is a tool to scan the image for known vulnerabilities. Yeah, very nice. It's a pain to get up and running, like some open source software, we all know that. It's written in Go, so you've got to fiddle around with it. But I did this talk in London about 6 months ago. Awesome gentleman called Armin said to me, hey, I've created a Docker image with Claire all set up and good to go. You just run this Docker image in your pipeline, and it will scan arbitrary images. Brilliant. Yeah? So you've got to do a little bit of magic. He's walked through all examples. There's like a bit of Go dependency fun as well sometimes, but it's brilliant. I literally did a Docker pull. This is OpenJDK. This is like the main. At the time it was November. This is the main way people were running Java in production. Yeah. So I pulled it. I just literally pulled in November. Pulled down the OpenJDK version of Java. I think it has Debian Jessie as the OS. I'd already built using Armin's stuff, and I ran the scanner on that. And this is the number of CVEs I found in my container. If you can't see it, it's about 100. Yeah? 100 CVEs. And I was like, what? and to be fair, some of them shouldn't be there, and that's, you can't always rely on people maintaining their image, yeah? Even like MySQL or well-known providers have messed up in the past. Some of these are completely kind of, we've known about them for years, or they've got a very small attack surface. But the point being is, we should know this stuff. We as architects, we as professionals, we should know this stuff. And I mentioned earlier on, there is a danger now where I think new regulations are coming in. We as developers, we as architects may be legally liable. And ignorance is often no defense in this case. Yeah? So these kind of things, they're really not hard to run. I'd totally recommend doing them. Yeah, and the containers do bring in that new dimension now. Also, we sort of hinted at earlier, you're typically running containers on a platform. There's something called kube audit. Who was, I can't remember who created that one now, but there's I think it was Shopify, created kube audit. It's a way to audit containers running in Kubernetes, so it's Kubernetes specific, but it will check for DAF security things that I've done in the past, and basically say, oh, you're running a root to user, you've not mapped this volume correctly, all these kind of things. There's Docker Bench, and there's Kube Bench, there's a bunch of other benches. They use the CIS guidelines, the CIS security guidelines, for running containers securely, and you can basically run them on a host, and it will look for issues on the host. Are the ports open correctly? Is the Docker daemon configured properly? Is the Kubernetes cluster configured properly? These are kind of, they should really be hygiene factors. Yeah, really quite important. I do get some pushback, and Rebecca set me up perfectly in the keynote here. A lot of teams I work with are agile teams, and I start talking about security, and I start talking about performance, and they go, whoa, we're agile here. We delay system quality to the last responsible moment. And I love the whole last responsible moment thing, it makes sense. But the newsflash is that sometimes the last responsible moment is up front, particularly for performance, particularly for security, definitely. Not thinking about these things. With containers, with microservices, actually makes it harder to put some of this stuff in sometimes. Yeah, and if you're not careful, it kind of leads to this broken Windows thing. Yeah, I can fix it right or I can fix it fast. Show you what fast looks like. Yeah, and I'll leave you to kind of fill in the code blanks there, whatever what that looks like. Right, so I'm getting quite close to time now. I might just whiz over a couple of bits here. So I mentioned about post-deployment QA. I'm not going to talk, I wasn't planning to talk lots about this, and I wasn't sure on time, but observability, monitoring is super important. Just bear in mind that using a container is another layer of abstraction. We love our abstractions, don't we, as engineers? But there's a platform in there, there's containers, you need to monitor that, and I put some references for you there to look at that. Doing things like canarying, so I'm working with Dedawar, we're using Ambassador, we actually created Ambassador. We're doing a bunch of stuff on A/B testing, there's many other tools that do this A/B testing. Kind of cool for testing small amounts of traffic in production, monitoring them, see if you get the response you want, see if your deployments are safe and so forth. Synthetic transactions I like a lot, so I'll often run happy path tests in production. So for example, I work with a bunch of e-commerce shops. Like if I can search for a product, view a product, add it to my basket and check out, I'm making money, I'm good. If I can't do any of those four things, the business is in trouble. So I often run tests of just basically doing those actions. We often reuse the scripts even, like using Serenity, there's a tool called Serenity, reuse the scripts from testing, run synthetic transactions in production. And if anything fails, or we're doing these kind of fake transactions, alarms go off and we try and fix stuff. You do have to be careful with analytics and reporting because suddenly that product looks super popular, for example. we actually made that mistake. The CEO came and said to us, hey, we're selling millions of this product, why is that? We're like, that's our fake product. I'm really sorry about that, that's not a real product. So be careful, but these tools are really nice. You're kind of separate to containers, but containers can give you that flexibility. Chaos engineering is the final one. I'm loving the chaos engineering stuff. I saw a Gremlin sticker actually on your laptop, so I love Gremlin stuff. But if you're using containers, you can do chaos testing. There's KubeMonkey, there's Bloomberg, they've got Powerful Seal. You can randomly kill containers in production and see what happens. Or you can kill them in staging first, probably safer, and have a look at these things. But containers do open up a lot of new possibilities. What I would say, when bad things happen, people are always involved. I personally like to be this person, kicking back with a beer, cashing the consultant paycheck. But just be aware, all these technology things, it just adds more and more layers. We need to be careful. And something I'm going to recommend is probably something close to yourselves more than me, but I'm sure you can remember the healthcare gov thing a few years ago. Out of that, Mikey Dickerson created this hierarchy of reliability. Fantastic, I put the link in there for you. Nori Hakkinen from Google, she's talked about this as well. And she's talked about, yes, you need your baseline monitoring. Containers add the extra layer. But I think Paul is actually talking next door about some of this stuff. But you need to think about the human aspect probably a lot more than the technology aspect as well. Finally, containers are not a silver bullet. A lot of people say to me, should I go all in? You know, and the vision for that, particularly from the vendors, looks super nice. I actually recommend starting a bit smaller often, yeah. What I've pitched in the past is maybe trying to containerize an existing application. There's for and there's against here. You know, it's a good learning experience. It can be difficult. For example, not on the high street, it was a Rails monolith, and it took us over 100 lines of bash to get it running in a container. Because it was just like, it was a super old process and we had to do all this munging in containers. But it did mean that we could push everything down the same pipeline. We had our monolith, our main business value application, going down the same pipeline as all our new microservices. So the pain was actually worth it. And we as a team learned a bunch about Docker and how Ruby ran in Docker, for example. Definitely need to conduct an architecture review if you are moving an old system into containers. Look for things like data ingress and egress, file system access. That totally tripped us up. Often, like we were using Passenger in Ruby, it was writing stuff to the local file system, and when the container got moved around by Mesos, I think it was, we'd lose that local cache and we'd get performance hits. So definitely, like there's a Simon Brown, massive fan of Simon's work. Susan's done a great post there. These are guidelines. We're doing architecture reviews, and yeah, a few sort of, I've personally been burned by these things, by the transients as well. Particularly the Java and .NET CLR and JVMs, they're optimized for long running. So when you stand them up, they take a while to get going. So you need to think about things like that. Final bit is using containers does not obviate the need for good architectural practices. I know I'm preaching to the choir here, but I have seen a bit of this sometimes. We crammed this monolith into a container and called it a microservice. Yeah? So please don't do that kind of thing. So in summary, I am a massive believer in continuous delivery. And I think the more we're moving to complex systems, my other talk talks about this more, but the more we're moving to complex systems, the more we have to rely on automation, the more we have to rely on pipelines and so forth. Serverless, microservices, containers, cloud, they've given us fantastic programmable interfaces, but we have to take advantage of that. When you're using containers in particular, think about sort of fundamentals again. The container image, there must be a single binary kind of going down that pipeline. Adding metadata, knowing what's in production is really important, particularly from a security perspective. Knowing what kind of OS we've got in production, knowing what kind of dependencies we've got in production, all these kind of things are really important. I often find myself working quite closely with developers on making them more operationally aware. This whole full stack developer thing now kind of includes ops. It's a complicated one, but often I've had to work, and it's no one's fault. It's just that you've got to take time to educate people and help them learn about these new things. Containers add a new layer in, so not all developers are operationally aware. Bear that in mind, and when you do learn things, assert them in the pipeline. Do your load tests, do your security tests in the pipeline. Tooling, as I'm sure you've seen today, it's a bewildering amount of tooling coming at you. Yeah, I apologise for that. It's I hope it was useful, but there is just a whole lot of stuff there. Stuff is becoming more stable now, and we just need to reapply the principles and practices, particularly from Jez and Dave's book, that continuous delivery book. Look at it, but reapply the principles with these new technologies, with these new tools. It's really important for us, I think, to capture all these things. Hopefully, bang on time there, I shall say thank you for your time today. Appreciate it. I think I am bang out of time, aren't I? So.
We have a couple of minutes for questions.
I appreciate 4:30 on an afternoon. It's quite hard to hold. Oh, yeah.
So I heard you talking about taking a monolith and running it through the same pipeline as your microservices. So does that mean you use the exact same CI pipeline to run multiple different products through?
Yeah. So we basically had there a pipeline that just validated our images. So it didn't matter. We had Ruby, Java, and Go. Yeah. So we either in the image kind of contained everything we needed, and we had our sidecar images that were respected whatever language we were using. So maybe different tools for Java testing, but fundamentally it was the same pipeline. So because we were humming and ahhing, we had this monolith, and we were going to have, it was a, I can't remember what it was running in, but there was a nice CI pipeline already working, but it was a completely separate technology. We were sort of thinking, do we have this whole new pipeline for container microservices versus this old pipeline? We wanted to homogenize it, so we had this kind of core steps. We could kind of plug in various bits and pieces depending on what was going down the pipeline, but that we knew everything going into production hit performance testing, hit security testing. And there may have been subtly different tests depending on the platform, but it was kind of the same gateways in the pipeline, if that makes sense.
And did all those, I'm just wondering about test parallelization. We have some big applications, small applications, and did they have vastly different test runtimes?
Yeah, big time. Yeah. So the monolithic Rails app, I think, took 3 hours, 6 hours to run the UI tests, like a Cucumber and a WebDriver, and our new microservices were tested all at the API level. Very lightweight protractor, I think, testing above. So yeah, that was a slight snag. And we even had developer experience. We were using, say, Git flow for the monolith. We were using just mainline development with the microservices. So there was a different kind of experience whether you're working on the monolith or on the microservices. But the ultimate goal was to kind of chip away at that monolith. That almost a cliche these days, but chip away at the monolith to move it all into microservices. But it got us up and running quite quickly. If we'd had to either chip away a large chunk of the monolith, for example, it would have taken us a long time. So by just sort of containerizing and then shipping down. Cool.
Just a reminder for everybody that in 15 minutes we have the SATURN 15-minute talks at the plenary in Delta. Thanks, Daniel.
Awesome, thank you guys.